Hello everybody and welcome back to I have a club by the name of Paul and Shelley. And Paul and Shelley have asked the question, JP, what does the P stand for? And Paul, Shelley, this week, the P stands for pivot. It's a big word that's been used a lot, but most recently, I know you guys are all feeling the need to rapidly pivot. In fact, 3 days ago, everybody was going hybrid. 2 days ago, now everybody is going distance. And the big question is, how can I do distance learning and distance education and do it right? My students, our students, your students are involved in all things like IB, AP, getting ready for things like SAT. And the truth of the matter is, there's only so much you can do if you send home vinegar and baking soda at home. I mean, it's a nice demo, but what are you really learning? And how is this really getting kids ready for what they need to do on assessments, or what they need to do in university, or what they need to do in life? Well, ladies and gentlemen, not to panic. Again, this week, we're not just going to show you the types of equipment that we have, or even go into the packaging. We have all of that, and we've done shows on that. This week, what we're going to do is actually show you how to teach with distance learning using our stuff. And so this week's show is entitled How to Teach at a Distance. And to help us kind of get in that mindset, we're going to bring in a couple of teachers and we're going to throw a couple of questions at you. And before we kind of get into that, let me get your mind ready. Let me give you some questions that we're going to be asking you throughout today's quick little program, because we want you to see how easy it is to do this and how easy it is for students to learn. So question number 1 is true, false. We can't wait to hear your answers. If you know them now, you can send them in. True, false, evaporative cooling is exothermic. Keep that question handy. You're going to see it again. Question number 2. Using your understanding of molecular structure, which of these is the correct order of highest to lowest boiling point? And you see that there are 4 choices there with 3 different solutions. You'll get to pick your answer. You're going to see this question again. And finally, those of you who are enjoying our physics, we have a new Tesla Model S. We know it can go from 0 to 60 in 2.3 seconds. And we want to know which one of those is true about the Tesla. So these 3 questions, again, as though I'm emulating distance learning and doing distance learning. Of course, I am right here. I'm in my home set. I'm working distance learning from my computer. Let me introduce who we've got around us so that you can see how we're going to bring this with us. I'm Dr. J.P. Keener. I'm a 30-year educator, a former director of STEM for the State Department of Education, and a PASCO consultant for education. Doing physics with us today is Mr. Dan Burns. He's also in the 30-year club. He's a STEM specialist and an AAPT recognized scholar. And doing chemistry with us today is Dr. Caroline Sayuki. She is an educator, researcher, chemistry specialist, and an educational consultant. These 3 folks, or those 2 folks and I, will be providing to you some great opportunities to see how distance learning is done. We're here, we're live, we're in our distance learning set here. We have folks that are taking your questions. If you ask your questions, they will direct them to me, and we'll be able to answer them back to you. Everything today is focused on our kits, and we've got some beautiful kits here, and it's all about the 10, 10, 10, 100. If you want to know more about the 10, 10, 10, 100, we have a show on our PASCO Live website. Go back and take a look, but we'll be doing the 10, 10, 10, 100 that includes the 10 labs that come in the lab kit, the 10 videos, the 10 data sets, and this great equipment. And to show you how we might be able to do that, let's take a look at how it's actually taught. It's time to flip this over to our own Dr. Caroline and the question that she wants you to think about, true or false, is evaporative cooling exothermic? Let's toss it over to Caroline and see if we can't get that answer as she does some distance learning. Dr. Caroline.
Thank you so much, JP. I'm going to consider you that kid that knows all the answers and sits in the front of my class every day. So, today's experiment is about evaporative cooling. I want you to think about a very important question. In fact, I'm going to ask JP this question. JP, do you ever sweat?
Not yet, Caroline, but I have a feeling you're going to try and make me.
I will
give it your best shot.
Absolutely make you sweat today. So, we are going to be talking about sweating and evaporative cooling. Evaporative cooling is nothing more than the chemical fancy schmancy way of saying sweat, what sweat is. So we're going to be running a very simple experiment today. We have 3 liquids in front of us: water, isopropyl alcohol, that's rubbing alcohol. You can get it at the local drugstore. And we have acetone, which is nothing more than nail polish remover. Everything we have here is something you can find at home. And we're going to do a really, really simple experiment, and we're going to have SparkView to help us analyze the data. Okay? So in this experiment, I'm going to take my liquid. In this case, I'm going to start off with water. I'm going to put it in a very small container. And I'll be using a PASCO wireless thermometer that I have, or temperature sensor that I have already paired with my program. And just for everybody's sake, just so you know, we actually have configuration files all ready for you. This happens to be Lab 11A in Essential Chemistry, and it's all set for you under PASCO experiments. So the experiment is really simple. All I have to do is take my temperature sensor, immerse it in my liquid, and when I take it out, I will press the go button. Now I want you guys to observe what is going on. As time goes on, you can actually see the temperature beginning to drop. What is occurring is evaporative cooling. Now we are going to just carry this out for about 30 seconds because just like in those Food Network shows, we already have data. I've actually run this experiment and carried every single one of these liquids tested to about a minute. Okay, so we're going to stop right here, right there, and let me show you what the data looks like. All right, so on the screen you see our 3 evaporative cooling curves. One of them is very shallow, that is of water. Now when you switch to isopropanol, you notice that it cools at a faster rate, bigger temperature change. And then finally, if you look at acetone, it cools very, very quickly for certainly the first 30 seconds. And then a rather interesting thing happens after 30 seconds. We'll talk a little bit about what all that is about. Now, I'm going to come back here and talk to you a little bit about why I use models. Okay, modeling, if you're a teacher, I cannot emphasize enough how important it is to use models when you are explaining chemical phenomena. Your students have to actually see how these constructs relate to the physical and chemical properties of molecules. So let's look at what water looks like. Water is a very small molecule. And when it is in a liquid state, it has very strong bonds with other water molecules because it's capable of hydrogen bonding. And as a small molecule, it actually makes it a very easy and very strong interaction. Now let's change and look at what's going on with isopropyl alcohol. This is isopropyl alcohol. It has the same bonds that will form hydrogen bonds with other isopropyl alcohol molecules. But look at what it has. It's got these large linebacker shoulders, and so it makes it a little bit more difficult for isopropyl alcohol molecules to form hydrogen bonds. Therefore, the interactions between these 2 molecules are slightly weaker than the interactions between water molecules. Now let's see what's going on with acetone. Acetone looks very much like isopropanol, but look at what disappeared. Where you had the hydroxyl group that's able to hydrogen bond with other molecules, you now have a carbonyl group. It's not able to do that. These interactions are much weaker than even your isopropanol. Everything else is the same. It's got the same linebacker shoulders, okay? Now, these structures relate very much to what you observe in evaporative cooling. They also relate very much to the physical properties of each one of these liquids. And in order to demonstrate that, we actually have this really cool interactive that JP is going to be showing you. Back to you, JP.
Thank you. Thank you very much, Caroline, and thank you for that nice discussion on modeling, and you're absolutely correct. As we are working with our students at home, you saw what Caroline did. She did a nice demonstration. She did the lab. Our students are watching, but you may want to connect with something that is a little bit more interactive, perhaps, that your students can work with, and we have that available in our Essential Chemistry, which is something that is available to you to help you with distance learning. So let me go to the book and show you exactly what I'm taking a look at here. So I'm in the book. You can see that I am in the teacher book. You see all the great resources that are on the left-hand side. And I'm going to open up this interactive simulation here of polar and nonpolar. You'll notice that I have both polar and nonpolar here at the bottom. Let me start with polar. I want to set the temperature to about 100 degrees, and let me push play. And watch the molecules, and specifically, watch the molecules as they rise to the top of the chamber. How many do, how many don't? And notice that I could be having a discussion with my students as I am with you. I'm going to switch it to nonpolar. I want the temperature to be the same. Again, with my students, I'm asking questions about what they expect to see. What do you expect to see? Those of you who are watching, you see that the molecules are now much more active, many of them reaching the top, some of them actually flying out of the top of the chamber, and I'm able to discuss this using an interactive that is right here in our curriculum. So we have been watching so far. We've seen Caroline. She's used some equipment. She's done a demonstration. She did a little bit of modeling. We conveyed that. We used a simulation. We continue to convey that. And Caroline now wants to ask a second question based on what we've done so far. And here's that second question. Caroline is asking, using your understanding of molecular structure, which of these is the correct order of highest to lowest boiling point? And so we have four options for you to choose from here. Acetone, isopropanol, water, acetone, water, isopropanol, acetone, and letter D, isopropanol, acetone, water. I will tell you I've got my choice, but let's see if Caroline can help us come up with an answer. Caroline.
So, let's think about what's going on in evaporative cooling, all right? And we'll sort of answer the first question first. When two molecules interact in a liquid form, they're fairly close to each other. In order for them to go into the gas state, which means that the molecules are going to be pulled far apart, they need energy. That energy has to come from the system. That means that evaporative cooling is endothermic. Now let's think about what happens when you sweat. The water evaporates out of your skin. That means those water molecules are coming apart. Guess who's providing the energy for that? You are. Therefore, you are actually feeling cooler because your temperature is going down. That is evaporative cooling. Now, based on that interaction, if you answered water, having those tight interactions has the highest boiling point, you would be correct. It's actually about 100, it's 100 degrees centigrade. Isopropanol has good interactions with other isopropanol molecules, except that those linebacker shoulders make it a little bit easier to pull them apart. It has a boiling point of 82. Acetone will have the lowest boiling point of all these three liquids. And in fact, it has a boiling point of only 56. So if you answered water, isopropanol, acetone, you would be correct. And I'm sure JP would be correct. And he's going to tell you a little bit more about how to analyze the data that we got today. Back to you, JP.
Thank you, Dr. Caroline. And absolutely, I did choose letter C. I hope you were also able to choose letter C. And remember, if you've got questions coming in, we want to hear them. We want to know about them. Caroline can answer them for you, or I can answer them for you also. But what I want to show you and talk about here on the screen is the fact that I can do greater analysis than what Caroline was just doing as she was just talking about the data and discussing the data. I can do greater analysis. In fact, if you take a look at what I've done here, I've taken the data that Caroline has shared with me, the student, and I've done some slopes so that I can actually look at the slope of those three different solutions. I can figure out the rate of cooling for those three different solutions, and I can do some analysis. Again, as a student, the software is free. The data came from the professor. I'm able to discuss it, share it, manipulate it, analyze it, send it back to Caroline, and have those types of discussions. And this is all part of that great little kit that we're talking about, which is why I keep pushing this 10, 10, 10, 100 that we've built for you. It's 10 activities right out of the box, 10 activities that come with 10 videos that are very similar to what Caroline did. In fact, if you want this video, Caroline has already recorded this one and it's ready to go. All you have to do is take a look at our 10, 10, 10, 100, take a look at these laboratory stations, find this distance learning activity, and you'll see what's there. Because the 10, 10, 10, 100 comes with all of the things you see here, plus these great sensors that you can do all types of activities, including pH, temperature, and pressure. And the exciting thing is you get 100% of the teacher resources. And for chemistry, that means you also get access to 100% of our AP chemistry resources so that you can be teaching both regular chemistry, honors chemistry, AP chemistry, using the same materials, the same activities, and the same process. Now, you want something really exciting? It might be physics. Physics might just be your cup of tea. And honestly, it's the same thing. 10, 10, 10, 100. We'll be looking at this physics kit. We'll be doing a demonstration with this physics kit, and we'll be relating it to our curriculum, the essential physics. If you need curriculum, we're going to show you how it all ties together. And to do that best, how about we bring in our physics teacher extraordinaire, Mr. Dan Burns.
Thanks, JP. You know, when I was in high school, my friends and I liked to talk about cars a lot, and we talk about how much time it would take them to go from 0 to 60. And we kind of wondered, what was the hardest part? Was it harder to go from 0 to 30, or was it harder to go from 30 to 60? So take today's Tesla S. The latest one can go from 0 to 60 in 2.3 seconds. Is it harder to go from 0 to 30? That'd be your choice A. 30 to 60, choice B. Or are they the same? Are they equal? And so physics is about coming up with a systematic approach to answer your questions, a question like this. And the lab I'm going to show you today would give you the knowledge that you would construct to be able to answer that question and many more. And so the PASCO wireless sensors, including our smart card here, not only do they help us answer these questions, but they help us answer them very efficiently and quickly. And so if you're in the classroom, students can then investigate further, doing analysis that normally would take all day in a lot less time. If you're doing distance learning, you can collect the data for your students, and then they can do the more important part, analyzing it, making sense of it, drawing conclusions. So I have our smart cart, and I've attached a string to it to the force sensor of the smart cart. So when I let go, that string is going to pull it down the track, and the force sensor will measure how much force is pulling on it. I also am looking at the position sensor. The position sensor will measure the position of the cart and its speed as it goes down the track. So let's take a look at the data collection. And so you can see the three graphs. Oh, almost lost it there. And so you can see the force data on the top, pretty constant. But to be a little careful, we could select part of it with the SparkView data tools and get the average. And then looking down at the position and the velocity graphs after we display our mean here, we can display using the multi-coordinate tool the position and the velocity at several data points to uncover what that relationship is. And so you can see it displays the position and velocity wherever I want to put the cursor, as long as you make sure you don't go up to the part where the velocity became steady. Also, another thing, notice the force drops right when I release the cart. That's an interesting thing to talk about. And so this data collection goes really fast, but the students need to be prepared before they do the lab. And the Essential Physics 3 textbook does that. And so Essential Physics, we could go to the chapter we're interested in this case, work and energy. And you can see a lot of detail in here. This is the teacher version. And then we can go to the kinetic energy part. We need to know what kinetic energy is to do this lab. And so there's a PowerPoint all ready to download. And so you could present this to your students in class in a remote learning session, or you can actually record your own narration and post this so they could asynchronously access it when they need it. And so you just go up to record slideshow in PowerPoint, and then once you're done, you can export it as a MP4 file and then post that to YouTube or wherever. And so the Essential Physics textbook gives you access to things like this so you can quickly be working to help your students learn even if they are at home. There's also a downloadable student note that goes along with this. Now, let's say you wanted to do this lab with your students. We've made that easy. Now, the answer to the question, well, the answer is up to you. And so if you go to that link on our website, it's experiment 856 in our experiment library, you'll see a link to a video of me collecting the data in detail, describing exactly what we're doing as we set up the experiment and collect the data, and the data file that goes with it with SparkView, which is free for tablets and devices. And we also have a free trial for PCs and laptops. And you can have your students analyze the data. The student handout is posted there, and even a Google form version of it. If you're using Google Classroom, you can put that right in, and your students can work on the lab. If you sign into the website as a teacher and get a teacher account, you can also get the teacher guide that goes with it. And so remember that, experiment 856, and then you can answer this and not have to depend on somebody else. So how do you like that, JP?
Dan, I would like that a lot, but are you honestly not going to give the answer?
No, definitely not. They need to find out the answer for themselves. Or how about we take your Tesla S out for a drive after work today, and we'll answer it together.
I love the idea. I love the idea. Thank you, Dan. So I'm not even going to give the answer that I guessed. And I hope that everybody does go back to the website and takes a look at the video that Dan suggested and recommended, and take a look at that data to come up with the correct answer. If you want to know that answer, just go back to the web, take a look at that very special website that Dan did collect all the data. And do notice that he was talking a whole lot about using our kit that's got all the equipment, our 10, 10, 10, 100 kit that's got all the equipment, and the Essential Physics curriculum. And please know, if you need a hard copy of the book, we can get you a hard copy of the books, but everything that we're demonstrating has been electronic so that you can do it online with equipment that you can use in your classroom, so that when your kids come back to the classroom, they'll be able to do the same experiments that you watch Dan do, that you'll watch any of us doing. You'll be able to do those same experiments with your kids when they come back to the classroom. So this is a great solution for hybrid and distance learning. And we're honestly hoping that you take a very serious look at this, because we want to help you. We want to support you. We want you to use these things, and we want you to understand that it's not just about physics, it's about AP physics, it's about getting our students ready for what they're going to face, and this includes 100% access to all of our teacher resources, which for physics includes both AP Physics 1 and AP Physics 2. We've got the full compendium of manuals available to you. And I see that we've got somebody coming in on the computer all the way from AtLab in the glorious UAE. Hello. Karpaga, nice to have you joining us today. All of our folks out in the UAE, thank you for saying hello. It's nice to have you. And for all of you out in the UAE or anybody around the globe, if you're missing any of the things that we've been sharing, by all means, check back in to our PASCO Live website and you can see all of these presentations. We've got them ready for you. If you want to know more about these 10, 10, 10, 100 kits, you're going to find them right here on our PASCO Live website. In fact, we have a very detailed explanation of what this whole 10, 10, 10, 100 is all about. Now, we always have a promo. Oh, we have a question coming in, Brett?
There's a question about pricing.
What's the price?
Yes.
What is the pricing? That's a great question. And we're not able to give you the exact price here. What I can tell you is that if you go to pasco.com, www.pasco.com, and type in lab stations, you're going to see all the things that we're talking about here. You type in lab stations, or you type in essential physics, and you'll see essential physics. But what I'm going to do for you and for everybody who's asking about that, I'm going to give you a special promo. And today's promo code is PIVOT. If you reach out to Isaac Martin by email, and you tell him you watched PASCO Live, code word pivot, he's ready to put together a package for you that includes equipment and curriculum. If you need it, we've got it. That includes curriculum and equipment at a price that you won't be able to refuse. It's a great offer. It's a great deal. Our website prices are posted. Go to the website and take a look. But I promise you, if you reach out to Isaac, you're going to come up with a much better deal than you can even see on the website. Reach out to him by email. Remember, our code word is pivot, and let Isaac take care of you. And for those of you that are international, Ms. Carpaga and all of our friends at AtLab, you know that we've got partners around the world. Reach out to any one of our 100-plus country partners out there and say, we want to be involved in essential physics. We want to be part of these lab stations. We want to bring this to our students, and we're going to help you. And so that's what we have for you this week, ladies and gentlemen. I hope you enjoyed the fact that we didn't just show you equipment, we demonstrated the equipment. And we did it in such a way that I hope you learned a little bit about boiling points and polarity. I hope you learned a little bit about motion, and though we didn't get the answer, which still has me upset at Dan, and we'll take care of that later. While we don't have the answer, we will be able to answer that through distance learning. If you want more great opportunities, especially in physics, to see how I can do demos in my classroom, you don't want to miss next week. Next week is PASCO Physics Friday, and it's not just a quickie. It is over an hour of physics demonstrations from our physics specialist right here in PASCO, running from 9 o'clock a.m. in the morning, 9 o'clock in the morning right here Pacific time, running until we're run out of demos, and we're going to be running that for you. You don't want to miss it. Absolutely. Take a look at what we've got for you next week. Fantastic PASCO Physics Friday. And for us here at PASCO, do we have any other questions coming in? We're good? Okay. So for all of us here, for our fan club at home, for Paul and Shelley who have a fan club who said hi, we're happy that you joined us. And to all of you, we wish you the best of luck, great teaching, and good day.